Hey, this is Sanyam Bhutani, and you're listening to Chai Time Data Science, a podcast for data science enthusiasts where I interview practitioners, researchers, and Kagglers about their journey, experience, and talk all things about data science. Welcome to Chai and ML Pipelines, ctds.show. In this episode, I interview two people who have literally authored a book on this title, Building Machine Learning Pipelines, Dr. Catherine Nelson and Hannes Hapke. Catherine is a data scientist at SAP Concur Labs, and Hannes is an ML engineer in the same company. As you expect, we talk about their journey into machine learning and their journey into this world of building machine learning pipelines. We dive into depth about the book, cover who's the book really for, what does it, what can you expect out of it, and in general, the challenges with building pipelines. The book is live today. You can grab a copy. Feel free to check out the links in the show notes. I really think this is one of the unique topics that haven't been discussed in depth in any other resource. So if you'd like to host a book club or join one that I might host later this year, please feel free to drop me a message or join Machine Learning Tokyo, where I'm currently very active. And we'd be happy to help host a study group on this. Now, without further ado, here's my interview with Catherine Nelson and Hannes Hapke. Please enjoy the show. Hi everyone, I'm on the call with Hannes and Catherine. We'll be talking all about building machine learning pipelines. Thank you so much to both of you for joining me on the podcast.
Thank you, Simon.
Thanks, great to be here.
With all the episodes, I usually start by talking about my hero's journey into the field. So I would like to start by asking you about your journey, Catherine. Maybe with you, your journey from, I think you transitioned from academia or research into the industry. Can you share a bit about your journey?
I did, yes. I actually started out training to be a geologist. I studied geology and geophysics, did a PhD in geophysics, and then worked in that industry for a little while. About 5 years ago, I decided to make a career change, and around that time, LinkedIn started sending me all these messages saying like, hey, why don't you come and be a data scientist? Data science. And eventually I clicked on one and I was like, oh, this sounds kind of interesting. So I liked the sound of it. I went out and I found a bunch of online courses to improve my programming skills in Python. I learned a lot about machine learning, and eventually I managed to meet a very wonderful person who referred me to a job at SAP Concur, which is where I'm working now.
Okay. Could you share a bit of the resources that you used at that time, and if you would have, I'm sure you would get this question a lot, but what resources would you recommend today for someone who's looking for that transition?
Yeah, this was back in like 2015, 2016, and like many people at that time, I took Andrew Ng's classic Stanford machine learning course, and that was a real breakthrough for me. And then after that, I took what I had learned in that and I used it on some data that I was interested in myself. And I think that was a really key thing to me, to take what I'd learned in these online courses and actually apply it to a different problem.
Okay. Hannes, would love to know about your journey as well. I know you transitioned from the world of electrical engineering. You studied electrical engineering into the world of Python. Can you share a bit about your journey and at what point did machine learning catch your interest?
Yeah, so machine learning happens along the way, sort of. I got really interested in like early beginnings of machine learning in high school. And then I basically forgot about this And it came back in my thesis when I went to graduate school, and I wrote about control systems for power plants, renewable energy power plants. And one of the controls schemes I tried was using neural networks. And back in the day, there was like 2009. It wasn't a deterministic system. There wasn't a hot topic, and I forgot about this again. And a few years later, it came back. Back then, I started a company. We tried to perform predictions about like the savings of renewable energies for individual households. And then we had a very specific computer vision problem, which we had to solve with machine learning. And so we ended up using convolutional networks. And back then they were popping up. They were luckily around in 2012 or 2014. And basically that's when I stuck with machine learning. And then from there on, I ended up working in a recruiting company, or I ended up in a healthcare company and retail startups where I applied those machine learning concepts. And yeah, now I'm also working with Catherine and at SAP Concur.
Awesome. So I think the company is called Renewable. Am I pronouncing it correctly?
Yeah, it's Renewable. Yeah.
Can you tell us more about that? And is it still functional? Are you working on some projects there?
So we discontinued the company in 2015 or 2016, I think. So the idea behind it was there were back in 2010, 2011, there were a lot of investments happening in renewable energies. And we saw like all the hedge funds and banks, and they're invested into government-backed schemes. And we felt like, well, those schemes, everybody can invest in them. And you can basically put up a wind turbine or a solar panel on your roof and you get paid for that. But we found when we asked folks, we're like, what's the barrier to get this done? We found that the entry barriers are so high. There's like tax regulations, there are like zoning laws, there are like all sorts of things to follow. And a lot of people just gave up at the very early stage of those projects. And so my friend of our Feto and I, we got together and built like a platform similar to Expedia for renewable energies, where you type in your zip code and you get the breakdown of all your savings in terms of money, in terms of carbon, recommended renewable energy sources for your house. And then we would basically connect you to solar installers or like wind turbine installers for like farmers, for example. And we ran this project until Google came out with a very competitive product. And they had the lucky advantage that they offered those services for free. The project is called Project Sunroof. And for us, that was sort of like, well, it's really hard to charge money for that service if a gigantic company like Google offers that for free. So that was for us a good moment to like, hey, we learned a lot. And we walked away with like a good experience in machine learning, a good experience also in like building machine learning systems into real apps. And I think that was really interesting. And I took a lot of learnings from there.
And sure, I really wanted to dive into both of your thoughts, because I think, Catherine, you as well have worked on some very interesting projects. I was reading that you worked on lava flows and similar things in your research. Just out of curiosity, would love to know both of your perspective on can we apply machine learning in these areas, because I know the interesting areas for machine learning are where it's underrated right now. Not many people are applying. So if you had any thoughts. Catherine, would you like to go first?
So I'm a little bit out of touch with where machine learning is in geology, but I think there's a ton of opportunities to use machine learning on the types of images that people use to explore for oil. There is some work that's being done in that area, but it seems like a really good problem to work on, because there's a lot of data out there. The challenge is that most of this data is held by giant oil companies, and they don't share as much as people do in the computer industry. A lot of that data is kind of held very closely. But I think being able to, one sort of area of research I see is that using machine learning on the physical data and not just the images. I think that's a really promising area.
Interesting. Yeah, I believe I've seen a few Kaggle competitions, but not as many. Even though, so I'm a Kaggler in image world. These were one of the very few interesting competitions where you had to do segmentations and all sort of interesting things on these images.
Yeah, was there one about salt not too long ago? There's an imaging competition.
I think that was one of the first ones that I got to compete in.
Nice.
Another aspect, and as I sort of walked towards the book, getting to know more about the book, I learned that both of you have been very involved with the community. Catherine, maybe we can start with you since we're already talking. You're
Yeah.
also organizing a lot of PyData events. Can you share a bit about them and how can people join who are interested?
Yeah, so I'm a community organizer for Seattle Pi Ladies, and that tries to bring together women and people of other marginalized genders who are interested in coding in Python. And it's a local meetup that gives ladies a chance to give technical talks about Python and network. And it's part of a global organization. There's Pi Ladies chapters all over the world. Cool.
Okay. Hannes, I saw a few photos of yours on Twitter. I remember, if I remember correctly, I I think both of you really enjoy giving talks. So, what all community contributions do you enjoy, and if you're active in any community right now?
Previously, I was involved in the Python community in Portland. It was a wonderful community when I arrived back in the US. I moved back in 2014, and it was such an open community. I lost a little bit touch with the community because of things are what's happening right now, and like also my focus has shifted away from Python, pure Python, to data science. But the community back in the day, we had PyCon happening in Portland here. That springboarded a bunch of events, and we had some really good sort of presentations happening, and it was a wonderful 3 years, I would say, and the community was really open to good topics. So I was very excited to be part of that. Also back in I think must have been 2013, we connected with friends from the Python community in Uruguay, and they invited us to give a talk there. And there's a lot of good events happening from there. And yeah, Python is just such an amazing programming language to open up the doors for a lot of people. And I was very lucky to be one of them. So
I'm sure it was a lot of fun. I wanted to pick this story up. I saw a photo of both of yours where you had a poster, I think not of your book, but some O'Reilly book. Was it at an event where you decided to write the book together? Is there an origin story to the book?
So I think I know the photo you're thinking of. We were at the TensorFlow World Conference in October last year, and we had just got the early release of the book out on the O'Reilly platform, so that we were celebrating that. But yeah, I think Hannes should probably start the origin story of the book, because a lot of it happened before I joined the project. And then I'll pick it up from where I joined.
Yeah, so where to start? So I was, as I mentioned earlier, I was working in these various companies, and we always built machine learning systems, we had to integrate them, and then we had models out in the real world, and we realized as soon as we would put them out, we had to update them. And every system was sort of like custom built for each application, and I felt like really cumbersome. So I looked into opportunities and different tools and libraries, and that started sort of the collection of those libraries started the idea of like writing a book around it, and which tools have we used and how to string them together. And then in March 2019, TensorFlow, the book was already describing some of the TensorFlow tools, but in 2019, Google released the glue code between those libraries, and that turned into TFX. And so that threw away a good chunk of the book. But the good thing is it opened up new opportunities because we could focus on describing the machine learning lifecycle. We didn't have to introduce like how to build those glue codes. We could just like, hey, here's the introduction of like how to combine component A with component B. And then we could focus on the orchestration of those components. And that was right around the same time when I met Catherine. And the book had really good sections, but it also had some gaps in there. And that was perfect a match for Catherine's background. Catherine's background, sorry, your background goes way beyond that, but she's an expert in terms of like model analysis and privacy, and that sort of springboarded into more and more chapters in there. So, but Catherine, take it from there.
Yeah, so when I met Hannes, which is at a conference in Portland in April last year.
I was wrong, unfortunately.
Oh, it was close, yeah. No, it took us a little longer than the 6 months to write the book.
Okay. Please continue.
Yeah, it was at a previous conference we met, and we got along really well. And a few weeks later, Hannes emailed me to say, like, would I like to contribute a chapter on data privacy to the book? And I was like, yeah, that sounds great. Tell me more about this book. And eventually this kind of snowballed into writing a larger and larger chunk of the book until eventually we were like, okay, we're co-authoring this now. And I hadn't actually used TensorFlow Extended at the time when I started writing the book, but it was an amazing learning experience for me. And I think that actually made me a better person to write it, because I had that beginner's mindset. I knew what problems people were going to have learning it, so I could sort of learn it and then communicate how I'd learned it with a very sort of short gap between the two.
Were there any changes for you both? Because I know the project took 20 months. TensorFlow 2 came out sometime in the middle of this. Did that cause more things to be thrown away at that time?
Not thrown away, but rewritten. We had an initial demo project, which carries through the book. So from chapter to chapter, we add more components to the demo project. But with the deprecation of TensorFlow 1 and the occurrence of TensorFlow 2, we rewrote the demo model behind the scenes. It used to be an estimator, and then all of a sudden we were able to use carries.
Okay. Sorry, Catherine, did you have something to say?
No, I was just thinking that was a constant theme throughout the writing of the book, because Google's model is to release things very fast and continuously. So things were constantly changing as we were writing them, which is quite a challenge. And even since we published the book just a couple of months ago, more additions have come out to make the project even better.
You could have picked Team Red instead of Orange. Why not pick Team Red? I'm more on the Team Red at this point in my career.
I think Ray wasn't. I don't know when Ray started. It showed up.
Sorry,
on the radar.
I meant Team Red, PyTorch. I'm referring to PyTorch as Team Red.
Sorry, I heard Ray, and I was like,
I'm sorry.
No. So the angle came from the production point of view of machine learning. Back in the day, when I started looking into those machine learning engineering topics, even the PyTorch folks converted their models to Caffe. And luckily they got around it. And the Onyx popped up, and then now we have Onyx runtime. But back in the day, TensorFlow looked very promising for production environments. And then, yeah, that was sort of like the starting point. And at some point, it's really difficult to switch and to go back.
I think even today, PyTorch doesn't have the same one solution that gives you an end-to-end production workflow. I think they have a lot of the pieces now, but not one thing that you can set up and automate. And I don't see all of the interesting tools around the detailed model analysis, which is something I'm really interested in.
So not as mature as you'd like the ecosystem to be.
I think they have a different focus. I wouldn't say, I don't know, I can't judge the majority there, but like PyTorch came from a research point of view, whereas TensorFlow originated with like, we want to get this out into the real world. And so I think both converge and they meet somewhere in between. But as Catherine said, like the glue code isn't around on the PyTorch side, that we can stitch those components together as we can do that in TensorFlow Extended or in the TensorFlow world.
Gotcha.
I'd love to see some future solution where it doesn't matter what framework the model is written in. You can just use all the same machine learning engineering pieces, whether you've got a PyTorch model or a scikit-learn model or a TensorFlow model.
We're all living for that future, most of us.
We're pretty close. I think we're pretty close.
I hope so. Can you outline the book writing process? I'll just get into the outline of the book as well. But what I've learned is the process of writing a book in itself is somewhat consuming. Hannes, I know you authored a book before as well. How was this experience for both of you?
So the book process generally starts with a rough idea and you write a proposal. And you submit that proposal to a publisher. That could be O'Reilly, Manning, Pact, and there are many others. And once that proposal gets accepted, there's usually, sometimes they get rejected outright or sometimes ping. That proposal then gets accepted. Then the work starts and like sort of like you have a very detailed schedule and you commit certain chapters to certain deadlines. And very early on, you basically know when the book needs to be ready. And there's very little wiggle room. So once the proposal gets accepted, there's a lot of work coming towards you. But you don't need to submit a complete manuscript when you contact the publisher. That's the key difference to other industries, I would say.
Interesting. Catherine, when you joined the project, how was the collaboration like? Because I worked on a few blog posts. I know the majority of us know how to write blog posts, but people really underestimate the book authoring process. So just curious on that.
Yeah, I knew it was going to be time consuming, but it turned out to be even more time consuming than my greatest expectations. But it was a process that I really, really enjoyed. We had a really great collaboration. We had a fantastic set of editors at O'Reilly who were super helpful throughout the whole process. I really enjoyed learning to improve my writing and get my thoughts across. And by the end of it, I felt like the process of writing the book had organized things in my mind really well. And that was very enjoyable.
I'm sure. I'm only halfway through the book right now, somewhat enjoying it. But I come from Team Red, so I'm slowly working my way through it. Can you, for the audience who haven't heard of the book, can you share who's it for and what can people expect out of the book? Catherine.
Go ahead, Catherine.
Sure. So here it is. Here's the finished thing. For the listeners, I'm holding up a copy of our book, Building Machine Learning Pipelines. And it is aimed at machine learning engineers, data scientists, and people who manage teams of those people who want to automate the process of retraining models that are in production, and a whole bunch of other stuff as well. Builds on a TensorFlow Extended framework, and you can use a variety of different orchestrators to run your pipelines. Hannes, do you want to say something more?
Yeah, so in the book, we're starting off describing a machine learning lifecycle. And the model is not just an artifact being trained, but it goes through a continuous cycle, as we think. And the cycle has multiple steps in there. It starts off with like the data validation or the data versioning, validation, feature engineering. Then we train a model, and then in most life cycles, it goes straight to deployment. But we disagreed with that, and we said like, hey, there's a step in there, model validation. And then once the model is validated and we actually compare this to previous runs, then we deploy those models. And then we talk about, like in the book, about data privacy, or sorry, machine learning privacy, and also feedback loops. Like how, once the model is deployed, how can we capture more data to make existing models better, or like sort of like springboard into new projects. And the idea behind the whole book is that if you follow that example project, you can then build up itself. And we're data scientists, and we got frustrated with like the manual work we had to do with existing models. And so by setting up the pipeline once, you can run through this continuously, and you capture more data, you retrain your model, and if the model is being blessed as in the TFX context, then it's being deployed and there's a new version out there.
But if something's happened further upstream and your data that comes into the start of your pipeline isn't what you expect, something's fallen over somewhere else in your system, then the pipeline will catch this and it'll say, no, my data is incorrect, or my model's accuracy is worse. I'm not going to deploy the model, I'm just going to stick with the same one.
Do you expect beginners also to be able to pick this book up, or do you recommend some prerequisites? Because many people just think, yeah, I got this accuracy, now I'm good enough, I'm going to move to the next problem. Who is the book for?
We don't cover anything about choosing your model architecture. So it's aimed at people who've already learnt about how to build their machine learning models. So they've read some other books or taken some other courses on the different types of algorithms and so on. But if you've got a machine learning model and you want to know what to do next, then our book is a great one to pick up.
I would love to also get into the outline of the book. I know there are, I think, 17 or 18 chapters. So if you could share the outline of the book and maybe dive into the details for what all is being covered, because I saw a few very rare terms that don't usually appear in machine learning books, and to let the Zoomers know, these are Apache, Kubeflow. Many people haven't even heard of these. So if you could highlight all of that.
Yeah, so we start, I'm referring to the book right now, and we start with an introduction where we just outline all the steps that go into the machine learning pipeline. So this is, as Hannes was saying before, we start with the data ingestion. So our data is sitting in some system somewhere. We want it to move into our pipeline in an automated way. Then we validate the data. We check that the data's statistics are the same as the training data. So we don't want our model to be trained on data where the split between the different classes is completely different to the training data. The next step is the feature engineering, where we transform the raw data into the features that the model needs. So whether that's embedding it into NLP embeddings, or taking numerical data and splitting that into buckets. Then the next step is model training. We don't talk about model architecture so much, but we do talk about how that automated training step is kicked off in the TensorFlow extended world. And I think that's about 6 chapters. Do you want to pick up the next ones?
Sure. So afterwards, we talk about the model validation. So once we have a model being model trained, then we would like to run it against the validation set, but also compare it against previous runs. Then we talk about another chapter that is deployment. So once we have a model trained and exported, like how do we deploy this? And we actually have 2 chapters in the book, because there's sort of like a simple deployment, and then we talk about more like the scalability of those deployments. Like often the deployment is when our machine learning models hit the real world. And if the model is very popular, then we need to work on scaling those instances. And we talk about like how can we monitor our deployments? How can we scale them? How can we integrate efficiency features, like, for example, using TF Lite on TensorFlow serving and things like this. And then
That's the point when a ML engineer starts getting calls around 3 a.m. if things aren't done correctly.
exactly, yep. We talk about like how to integrate Prometheus into your deployment environments and to get those log files quickly when you wake up at 3 a.m. and get that call. Once the model is deployed, that is basically sort of the end of the TFX world. And then we have our pipeline, and at that point we can talk about how do we actually orchestrate that pipeline. So each chapter is its own component. And then in the following 2 chapters, we introduce 3 different concepts of orchestrating those potential pipelines. And those orchestrators have their advantages. So in the first, I think chapter 11, we'll talk about Apache Beam and Apache Airflow to orchestrate those workflows. And then in chapter 12, we talk about Kubeflow and how to set up those pipelines in those respective orchestrators and how to coordinate them and how to run with them. And then chapter 13, I think I can't remember exactly. Is it data privacy or is it feedback loops?
13 is feedback loops.
Okay, so in feedback loops, we talk about the concepts of like once your model is out, how can you capture new training data from user feedback, which can then be fed back into your pipeline to kickstart to start up the data ingestion again. And then chapter 14, there's a wonderful chapter on data privacy. So how can we train machine learning models to be respectful to the data and to the model itself. And then in chapter 15, we provide an outlook of like what's happening in the next coming months or years. And there's a bunch of like appendices in terms of like how to set up Kubeflow and Kubernetes and things like this. So that's how we end up with those 18 chapters.
For the last few chapters, you mentioned feedback loops and privacy, machine learning privacy. How do you recommend people should approach these? Because for feedback loops, either you have to pull the plug if things go really bad, and they have gone bad. These are, I think, somewhat still under discussed in the community. I would love to know your thoughts.
Definitely, because it's incredibly complex and also very specific to the individual problem that you're working on. So not that many companies have shared stories. I'll put a few examples in there, but there's things like, there's a really great example from Stripe where they were looking at fraud detection, and they shared some of the learnings around that, where they found that they had to let a certain proportion of fraudulent transactions actually go through so that they had the correct training data for their next models. So hopefully people will share more stories like that so that we can kind of get some common learnings out of them.
What tools do you think exist today? I know there's one that Andrew Trask is leading for privacy, federated learning in general. Are there any other tools, or would you say this is still in early stages?
Yes, it's just starting to make the leap from research to something that to tools that we can actually use. The group that's led by Andrew Trask is called PySift, and they are doing a bunch of stuff on federated learning and other tools. There's also some tools coming out from within Google as well. They have the TensorFlow privacy library, which uses differential privacy and puts that directly into TensorFlow. And they also have the TensorFlow federated library, which that's federated learning, which is when your model isn't trained in one central location. It's for when you have data that's dispersed across lots of different devices, so like people's mobile phones, for example. And what you do is you send updates from each individual device at the time and bring them together in a central location, so the raw data never actually leaves a person's phone, which is kind of cool.
And like you mentioned, these are early days, and we hope that these things come together. I think the book could be a nice way for people to learn about these and put projects together. Would you have any suggestions for people who are maybe new to the field and are going through the book? What projects should they aim for? Because some of these things can only be experienced in the industry. For someone who's learning this by themselves, what would be your suggestions?
Yeah. So I think any project where you're looking at data that involves people, this is definitely a fun thing to investigate. I think the differential privacy side of things is a little easier to get started on because that can be done just on one data set on one computer. But I think it's something that a lot more people should be aware of because there's this conception that if you increase privacy, then your accuracy is going to decrease. But that's not actually the case. These technologies are trying to make it so that you can win in both directions. You can have increased privacy and keep the same accuracy. I think that's a really promising thing to keep an eye on in the future.
Hannes, do you have anything to add or any other project recommendations in general for people going through the book?
Yeah, I think when we take a look at machine learning systems and we put them in the real world and we move away from like those clean data sets, it's really important to take a look at the data ingestion and data validation. I think that's the biggest learning over the last couple of years of just how to handle that and make data really the first-class citizen in those machine learning pipelines. It's almost less the model, it's more the data to get started. And then the concepts of like data will never be clean. Like how can we then deal with those dirty data sets? And there are various concepts we can apply. And I think to get started is like, it's always good to look into real world applications. And you said you're a Kaggler. I think that's a really good, I had my biggest learnings from Kaggle competitions where you get really invested in a solution or in a problem. And then you see the winner and you're like, oh man, this was like this tiny change in the network made.
Why couldn't I think of that is the usual reaction.
Yeah. So there's good learnings coming out of those Kaggle competitions. And in terms of, there's good literature out there. Aurélien Guérin's book about getting started with machine learning and TensorFlow, that's sort of the first book I would go to. And then Catherine mentioned Enderang's Coursera class in machine learning. And I think there is now a class on deep learning as well. I think there are good resources to get started. And then if you get into real machine learning applications in terms of hitting the real world and trying to reduce the manual labor, then I hope you come back to our book and you can read about automating those pipelines.
I'm sure I hope to do a study group later this year, but if anyone else would like to start a study group, I think it's definitely an interesting book to get your hands into. I would also love to know what other tasks are you working on, and this is one of my favorite questions to ask recently. What does a day in your life on non-pandemic days look like?
So besides machine learning engineering, I'm looking into NLP systems. So for example, extracting receipt data, entities, vendors, amounts from images or OCR data. Recently, I've spent a good amount of time looking into like transformer applications for named entity recognition or QA models and things like this. On a really good day, I have a clean data set to work with. So my model converges fast and not very slowly. But I think on normal days, it's like 80-20 rule, I would say. It's 80% of the time wrangling with data and then 20% coming up with a decent architecture. And then it's often performance problems. It's like, oh, we have a data set which is like a couple gigabytes big. How do we can't hold this in memory, so how do we process this? That's usually what I'm facing and what I'm working with.
Yeah, because all our data at SAP Concur, it's all around business travel and expense. So a lot of what we deal with is receipts. And you think, because people, they have some business expense, they want to get reimbursed for it, and they submit a receipt for us. And you think that, oh, all receipts are roughly the same, you have some idea in your head of what they're going to be like, but the data that we get is incredibly diverse because it's coming from all around the world in all sorts of different currencies. It is really huge and challenging data set to work with. So like Hannes says, we spend a lot of time wrangling that data. And at the moment, I have a really cool project I'm working on where all around sustainability, we're looking at trying to track carbon emissions from your business expenses, particularly around your business travel. So we're trying to use machine learning to help automate that process of extracting the emissions from your receipts. That's a really fun project to work on.
Interesting. Will you publish about this? Is there anything that people can keep an eye out to know more about this?
We put a lot of things that we can share publicly on our blog at concurlabs.com. So that's a place to follow us.
Okay, I'll have that in the show notes for anyone who wants to check it out. I'm approaching my final question. This is a repeat question on the podcast. Every time I get very rich and diverse answers. What would be your best advice to someone who's just starting their journey in machine learning or just starting their TensorFlow journey?
I would say that my best advice is to find a problem that you're really into, that you want to solve for yourself, and don't get too hung up on what technique you're going to use to do that. Find some data that you're interested in and use that to solve a problem with machine learning. And then share it with as many people as you can. Talk to your friends, talk to your family, and get their feedback on it. And just kind of get out there and try things.
I agree with that. Start with a real problem, maybe a real business problem. Even. Sometimes an employer has like an issue they solve manually, and you can do this with machine learning. But my advice would be also look behind the scenes. We mostly work with Python, and everything is source code. So we can, almost anything is available on GitHub. So we can see a function, we can drill into this function and also understand it. At some point, we're gonna hit some C Python. So I think then that's the end. But there's sort of like, there's a lot of good knowledge happening, which these days we take for granted. I love Hugging Face. But these days, a lot of folks start using transformers without understanding the limitations or like understanding what's actually happening behind the scenes. So if there's a little tweak there, here and there, or maybe you have a performance problem, then looking into the code or looking into a little bit more in the background, I think that would be my advice.
Me from a few months ago didn't know you could combine C and Python. I would have thought, what is C Python? But that's very valuable advice, I'm sure. Before we end the interview, would you both want to mention any platforms where the audience can connect with you?
Yeah, feel free to connect with us on Twitter. We have a website for the book as well. I can share the link for that.
Sure. Hannes, how about you?
Same. The best way to get in touch is via Twitter, and then, as Catherine mentioned, we have our book website where you can find references to the GitHub repos, and that's also a way to get in touch if you have questions about the implementation that we provided.
I just turned around to look at your handles. Catherine's handle on Twitter is Dr. Cat Nelson, and Hannes is his first name and his second name concatenated. Thank you so much, both of you, for joining me on the podcast and also for writing this book. I'm slowly making my way through it, but I hope other people would really enjoy it.
Thank you. Thanks for having us.
Yeah, thank you for having us.
Thank you so much for listening to this episode. If you enjoyed the show, please be sure to give it a review or feel free to shoot me a message. You can find all of the social media links in the description. If you like the show, please subscribe and tune in each week to Chai Time Data Science.